Physics?
Max.
No, physics.
Physics, we're learning now laws of force, of motion. Sorry, laws of force, motion and force.
Okay. So
We're
how is your
on the.
performance in classroom?
It's good, sir. It's good. It was better from how I was before.
Okay. Okay. Your mama used to send me the long voice notes. Okay. So did you completed the notes question answer? Did you got your reader? Did you get your reader?
Yeah, I got it.
Okay. So did you read yourself?
Yeah, I went through it.
Okay. So now tell me, how do you feel when you read the line by line of NCERT book? The chapter 8 is force and laws of motion, right? That's the
Yeah,
chapter being taught at school, right?
yeah.
So now tell me, how do you read the textbook?
Like how the teacher teaches
No,
us.
no, no, no. First question, how do you read? Kindly on the camera is possible, if possible.
So you're it's cutting for me. I can't understand what you're saying.
No, I'm saying that how do you read book on your own?
It's now easier.
Okay, easier. But how you read? For example, I'm sharing the screen with you. This is the chapter. I'll take not much discussion. I won't do much discussion. Okay. But I'm asking you, this is visible to you?
Yeah.
Okay. So how do you study the chapter? How do you start the chapter? My point is that.
I I read through the chapter and mark the important points to by heart
Okay.
and study.
So for example, this is the statement. I don't know whether I can write over here. We describe motion of an object along a straight line in terms of position, velocity, and acceleration. And this is saying about the previous chapter. Means that previous chapter, the writer, the editor of this book, wanna check your previous knowledge. See,
Yeah.
every knowledge is based on the previous knowledge. There is a steps. What are those steps? First, you ask your friend, the people you meet, the guy you meet the first time, you ask his or her name, right?
Yeah.
Hi, and then you say, what's your name, right? You get his or her name. Then you try to find, oh, from where you are coming, right?
Huh.
So first of all is
Yeah.
knowledge. So you got the knowledge that what is he. Then you are trying to understand his behavior or character or the geography. By asking from which area you come means you wanna understand about his economical situation, geographical situation, okay, and a
Okay.
number of things.
Yeah.
Do you agree or not?
Yeah.
Name is just name, the ABCD, whatever it is.
Yeah.
In meanwhile, you also try to judge him or her by the way he responds, by the body language, he or she responds to you. We do that, right?
Yeah.
So based on all those things, the writer is saying, asking you to see the previous knowledge. As he said that previous chapter, he says that we described the motion of an object. Now you have to recall what is motion. Got my point? You
Yeah.
have to clear your mind what is motion. Unless until you are not confident about the motion, you don't, you could, you shouldn't move further.
Okay.
Got the point? Along a
Yeah.
straight line. What is a straight line? You have to
Means
keep in mind. I will only do for one paragraph. Don't worry. Okay, I won't kill the time.
okay.
In terms of position, now you have to think what is position? What does it mean? What could be the position? How we will define the positions? Okay,
Okay.
velocity. Now you have to see what is velocity, acceleration. These all terms, position, velocity, acceleration, these all terms you have to refresh in your mind. If
Okay.
you're not getting, go back and read.
Hmm.
One of the sign Nobel laureate, okay, his name is Feynman. Feynman. If oh my gosh, this is the pen. If I could select it, I can't write over here. I think that's the thing, na?
Yeah, it's only highlighted.
Yeah. So his name is Feynman. Okay. So what does it say?
Okay.
Whenever you read something, any chapter or any paragraph, you first try to make yourself, you explain those paragraph or sentence to yourself in the simplest way. Okay.
Okay.
Doing
Okay.
that is just take a rough page or paper and then write whatever you have studied in your own language and then
Okay.
read or match with the given text, right?
Yeah.
If you feel that the knowledge is being incorporated in the your own words or writings, then it's okay. If it is not like that, go back and read again and
Okay.
repeat this situation, this process, unless until you are not aware to express those information in your own words. Got the point? So
Yes, sir.
after reading first line, you have to, I'm not getting all these, what is happening? You have to build your own informations, okay, using your previous knowledge. What I did with this, by the way. So you are aware of velocity, acceleration, whatever it is, you are aware of everything?
Yes, sir.
Okay. Now you will make notes. If you are not aware of anything, you will see. We saw that such a motion can be uniform, non-uniform. Now you have to recall in your own mind what is uniform, what is non-uniform. If you have any doubt, you will check in the books, right?
Yeah.
We have not yet discovered the cause of motion. Now he is telling the motto of this chapter or aim of this chapter. Okay. We have yet not discovered the cause of motion. What are the causes of motion? Why do the speed of an object change with time? Do all motion requires a cause? If so, what is the nature of this cause? These are all the question is being asked directly. And
Okay.
either if you know the answers, it's okay. Now you will read the book text. If your previous knowledge, you are knowing what is motion and the given knowledge matches with the concept, is okay. If it
Okay.
doesn't matches with your concept, now you have to work on your what can I repository, what repository you got into your mind. Either you will, what you will do, either you will uh, is the scientific term being called accommodation, assimilation. In psychology you will study. So if your previous knowledge and current knowledge doesn't match, you have to accommodate the thing, right?
Yeah.
In accommodation process, either you have to omit your previous knowledge and acquire the or accept the or keep into your mind the updated knowledge.
Yeah.
This is only this is only the conflict. Either your previous knowledge is correct with the current, or the current knowledge is conflictive in this. So you have to remove the conflict. That conflict is called confusion in the day-to-day life.
Okay.
Got the point?
Yes, sir.
Agree? Hope
Yes,
so.
sir.
So you have to work on that. We all have to work on that. So these all the questions we have to answer. In this chapter is saying that again, in this chapter we shall make an attempt to quench all such curiosities. This is a very beautifully written first paragraph. He connected with the, or he or she connected with the previous knowledge, and then saying about the future plan. How do you study?
I learn, I will read through the chapter and underline the sentences or paragraphs which are important to learn.
Okay. So whenever you feel that some concept or some keywords you are not getting, so how you remedy that?
If uh, if the word has been used in other chapters before, I would look through them, or I would underline that, highlight it, and ask the teacher if since I have a doubt.
Oh, that's good. That's okay, no problem. So this was, I think, out of content. Okay. So hope you
Okay.
will do better. So how do you attempt the question answers at the end of the book?
I try to answer it myself, and then if I look through it and I study it again and answer similar questions related to that.
Okay. So whatever the answer you have from your previous knowledge, do you check it with your the text statement, or whatever the teacher is saying from that?
Sir, could you repeat again? I didn't understand.
Okay. So for example, you answer some question on your own, right?
Yeah.
So how do you um, rectify errors or concepts? Do you use books to rectify whether that answer is correct or not?
Yeah, I look through it and I see if it's correct or not.
Uh,
And if it is, then, and if it's wrong, then I do it again.
that's good. So, did you try to answer the questions given in this text?
The questions,
Maybe
not
there are few questions at the end of the chapter, right? Or activities like that. These questions, these questions. Which of the following are more has more inertia? A rubber ball and a stone of the same size. How do you answer such questions?
mm,
Means that if you are asked to solve these questions, how will you proceed?
um, if first I'll try to answer it myself.
Yes, good.
First I have to like think through my knowledge and
The knowledge is
um,
based on your study, current
what I've
study of this
learned.
chapter,
What,
means that previous knowledge, right? You will try to check your previous knowledge, right?
yeah.
Okay. On the basis of that, you will try to answer.
So for the first one, rubber ball and stone, the stone will have more inertia because inertia is dependent on the mass of the object. So if the mass has a greater mass, then the inertia will increase.
Yes, right. So there is two points. There are general state. There are statements. Oh my God, statements. Okay, and another is mathematical equations, right?
Yeah.
So do you incorporate the mathematical equations?
Meaning, do I answer the numerical questions?
No, 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 no. Now let me share the screen with you for whatever I am trying to say you. Let me write it over here. For example, I'm writing over here. No problem, na? So we know that what is inertia? Inertia is directly proportional to the mass, right? INRCR. Inertia is nothing but the mass, right? Oh my gosh. Nothing but the mass, right? Inertia is nothing but the mass. Agree?
Sorry, sir, my internet was slow.
Your internet is slow. Okay, no problem. So the question was about inertia, right?
Yes.
So we said that inertia, where is inertia? Maybe somewhere it will be. Leave it. So INERTIA, inertia is related to mass. That's the thing.
Yeah.
More inertia, more mass. More mass
Yeah.
corresponds to more inertia, right?
Yes.
Inertia. That's it. So my point was that you made a statement about inertia, right? What is
Yeah.
inertia? So do you try to incorporate the mathematical equation for that? X, Y, Z.
F, some like for other questions I usually do with the mathematical, but inertia I don't usually, because then for inertia I use the daily life activities, how it is, and I compare them. Then I understand.
So you, for example, try to make yourself more expressive. Okay, how to express the things? You have to generate idea. You have to generate ideas. How we will
Yeah,
generate ideas?
by daily life, how.
We got the daily life, how the inertia, if one small car and big truck both collides. We know, take it. We know that that's happened. So
Yeah.
now it's time you just given the statement, statement. You given the statement, either the one sentence, two sentence, or three sentence, whatever it is required. Now uh, try to make your statement in the mathematical form. MATHEMATICL, mathematical form. As far as it is possible.
Okay.
Okay. So for example, we given the statement for the Newton's first law. Newton's first law, we given the statement.
Yeah.
We all know what is the first law of Newton. The law,
Sir.
Newton's first law. So
Yes, sir.
merely given a statement is not enough, right? Now you have to
Yeah.
give the mathematical forms. What is F is equal to mass time acceleration, or whatever it is. Got the point? Now
Yeah.
given the form, mathematical form, you have to define everything. F is force, M is mass, A is constant acceleration. Got my point?
Yeah.
Just not write if it's equal to MA and leave it. Give, where, say where
F is equal to MA.
where F is force, like M is mass of the object,
Yeah.
M is mass of object, right? So
Yeah.
in this manner, you will uh, get the ideas. Sometimes we write the equation just it, but we are not aware what the quantities are. Then we face problems in the application.
Hmm.
Whenever you get the problem, numericals, you will feel that you are not able to, maybe you are not able to recognize which quantity is what, right? This is one of the
Yeah.
things. So if you will build your habit, then you will be able to recognize the problems in its own way, right?
Yeah.
So once you have written what is all this quantity, what next could be? You have to think what next good information we can provide to the examiner. Not we don't we not do everything for exams, but to understand what else we can do. Mathematical statement we given. What else we can do? Or it is sufficient to close the answer, or we further can move. You are you getting
Hmm.
the point?
Yes, sir.
Is there anything we may say the dimensionality of it? We'll add the point dimensionality, dimensions, dimensions. We will write the dimensions. What is the dimensions? What is the dimension of force? What is the dimension of acceleration? If it's being, if it's the elaborative question, you have right to do. Okay. But make
Okay.
sure you have to maintain the time as well. But whenever you make the notes at home, you try to cover all the aspects of that question.
Okay.
Try to complete the horizon. Okay. Don't
Hmm.
just be in hurry. If you have no time, then leave it for the next time. But don't be in hurry. If you will skip something, then it will be remain aside. It won't help you much. So we given the dimensions. Now see, in the given context or chapter, you have to give some examples as well.
Okay.
Examples. But give the examples that are being related to the concept. There are a number of examples. Okay, for example, you are talking about the inertia. What is inertia? So this example is very real. This example, do you feel that this picture is relevant for inertia?
Yeah.
How?
Because as soon as the boy is catching the ball is giving a force to him and it's pushing him back.
So be, this is because,
Of inertia.
yeah. So if you feel that this is the right example, you give at least two examples, right? One
Yeah.
and two examples. Now, this is, I think with example, you may end the question or answer. Question answer, the same thing, right?
Yeah.
So if you follow some standard steps, I think teacher, finally we have to acquire good marks now.
Yeah.
This is the truth. Okay. So you may get some advantages, right?
Yeah.
So whenever this class will over and you may be having some homework from your school,
Hmm.
what the part you have studied, now try to answer those questions, right?
Yeah.
So again, I'm back. I think this is clear.
Yes. So
So maybe someone else will tell you in some better way. No problem.
okay.
So this was the question. So a rubber ball, you may add the rubber ball and the stone of same size. Why you think that a stone of same size will having the more mass?
Because the stone has more mass than a rubber ball.
But why? It says that the size is same. Stone is
Whether
of the
the
same
size
size and rubber.
whether,
Ah,
whether the size is same, the quantity is more.
volume being occupied by a stone and the rubber ball is same. So how could you say that one has less mass and one has more mass?
Because
This is
rubber,
the logical question, na? Same
yeah, but
same
it's just
volume.
I know
Hmm.
I just know the weight of a rubber ball and a stone. That's why I know stone has more mass. Uh,
From where you got this? If I
from
will
a
paint, see, if I will paint the rubber ball with the same color and that stone, the same shape stone, okay, with the same color, and I won't allow you to touch. I will keep just away from you. Then how could you decide that whose mass is more or weight is more?
um,
We will,
there'll be a 50% chance.
yeah,
Would
50% chance. So there are some fixed pattern. Okay, using those pattern, we will be getting the ideas whose weight is more or whose mass is more. So there is one
yeah.
quantity we have studied in our, what can I say, fluid mechanics, fluid chapter. There was something called mass per unit volume.
Unit volume.
That's the density, na? Mass density, volume
Yeah,
density. The rubber
density.
ball is what? The atom is not that much tightly bound with respect to the stone.
Yeah,
So if you are expressing yourself from very beginning, then it will be helpful for you to understand the concepts, right?
yeah.
So if you have extra knowledge, try to show it. Okay. Try to sell it.
Okay.
Of course, if the rubber ball and a stone are of same color, then who will see that? Okay, what is what? But the here, the question is already, the question is directly saying it's the rubber ball and another one is a stone. So it's clear, right? So, question is clear.
Yeah.
The question is again the bicycle and a train. 5 rupees coins and 1 rupees coins. If you'll see the pattern is same.
Yeah.
In this question, 5 rupees coin and 1 rupees coin.
Hmm. Five.
How you will decide? If somebody has not seen the 5 rupees coin and 1 rupees coin, it's a very variable thing now. It's not always true that five
Then
rupees. Huh.
they wouldn't they be the same size? Like it's 5 1 rupee. Uh,
Got the point?
yeah, but I'm confused which one
Five
because
one
five
rupees
rupees.
coins and 1 rupee coins means
Aren't they
that,
the
yeah,
same?
no, but you have to take 5 1 rupees coin, not single one. Five. Make
Oh,
a make a stack of five. Okay.
I thought they meant there was a coin written 5 rupees.
I that's the variable thought. It may be only 5 rupees coin.
Sir, is there a 5 rupee coin actually in India?
5 rupee coins, yes. But I think it is 5.
Even I was thinking also 5 of 1 rupee coins. There's 5 1 rupee coins together, but I was thinking it was 5 rupee coin.
I think it is also the 5 rupees coin. The single coin of 5 rupees.
Yeah, so aren't these the same?
Yeah, it's a single coin. So I don't know how people will see. This is the English
I
now. This is the S over here. 5 rupees. This is the S over here. Okay. So
it
this
then
S,
they should say coins. If it's multiple coins, they put it. So then it should say rupee coins something.
the play with English. Okay. So play with English.
I was yeah.
Got the idea? Or is
Yes,
still
sir.
okay.
No, I understood.
Similarly, if we will move to the further question, in which of the following example, in the following example, try to identify the number of times the velocity of a ball changes. A
Okay.
football player kicks the ball to another, kicks a football to another person of his team who kicks the ball towards the goal. The goalkeeper of the opposite team collects the ball and kick it towards a player of his team. So how many times do you think that velocity will be changing? How will you answer? Did you get any picture in your mind? Pictorial representation. When I say the picture, it means that first you have to imagine the thing in your head. Okay. And then if you are able to make the drawings, how the
Hmm.
ball is going, okay, from one player to another, another to goalkeeper hit backs. So,
Hmm.
so if you can do in that sense, so it may visualize the reader, or reader will understand in very simple way. He or she doesn't have to make much efforts, right?
Huh.
It's better you draw some sketches and then a response, right?
Uh, no, I think I understood.
Okay, so let me change and come to the point again. For example, the way this screen is visible,
Yeah.
so I won't take much time. I think today we couldn't study much, just the general talk. It's okay, or should I start the revision?
I'm okay with anything, sir.
So if you feel that it's not useful, then we may start. What we mean by the pictorial representation, that the situation is that first the player is kicking a ball to another mate. So it is one, this is two, and then he or she is again pushing it to the another mate, right? This is three, and
Yeah.
then
The goalkeeper
to the,
catches it,
yeah,
throws,
and then
kicks it to the.
another friends. So if you are able to make some drawings that this book has shown over here, right? How this is being changed. Okay. So at least you will understand the how many times the velocity is being changing. First, he has or she has v1 velocity. Now here will be v2 velocity. It is the name. Here it is v3. Here it is v4, and finally it will be v5. As you are changing the direction, velocity is being changed, right?
Yeah.
That's the clear. So pictorial representation means this. If you will draw this graph against that question, I think the reader will get uh what? Reader will be happy.
Yeah.
Do you think or not?
Yeah. He or she will think you put extra effort to answer.
And then he or she will award you more marks as well. Of
Yeah, maybe, yeah.
course, these are
Okay.
some experience, nothing else.
Hmm.
Reading again and again, she will too get the experience. Okay.
Yeah.
So now you have to write down all the question answers.
Okay.
Uh, did you study this chapter in the class? This topic in the class?
In school?
Yeah.
Yeah, we finished. We started to, this week. We started with the third law of motion.
Okay. Third law of motion means that second law and third law, right? So at least you might have attempted all these questions or not. Or teacher will.
Yeah, yeah, and she makes her own questions and gives it to us to practice.
Okay. With answer.
She'll only tell the answer after we do it.
Okay. That's good. So also it says that also identify the agent supplying the forces in each cases. How we will identify? Already is being said. If we will draw the sketch, then it will be clear how many times it's being applied, right?
It's 4 times.
4 times. Explain why some of the leaves may get detached from a tree if the vigorously shaking its branch. Why?
Uh,
Why this happens? Can you do the same with coconut?
uh, no, there is some chance where the coconut might fall, but most of the time it doesn't fall.
Because we can't impart the force to the tip. If the coconut tree is high enough, that's not possible.
Yeah,
How we will transmit the force to the fruits? Nowadays there are short coconut tree as well, right?
yeah,
But those are for what can we say? For the show purpose, right?
yeah.
That's barely get fruits.
Hmm.
So can you explain why this happens?
Because when we're shaking the branch of the tree, we're shaking it in a, how do you say this? Uh like a to and fro motion, like shaking it vigorously. So
Mhm.
the leaves attached to the branch resist, like blocks the motion of the branch um because of the inertia.
Right.
So
That's the key word.
um yeah, and and it's there is no like what you say, the leaves are not like like very strongly attached to the tree, so it will it'll not remain on the branch forever if since we have shaken it vigorously.
But it's not true for all the leaves. The leaves which are
Like
grown
the
up
weak
enough.
leaves.
Yeah, grown
Yeah.
up enough. Okay, so after one time they are lightly bind with the tree with the stem, right? So detaching those leaves are bit easier than those which are new. What can I say?
Yeah, yeah,
Newborn.
yeah.
Yeah. So This is the pure phenomena why this happens. This belongs to biology, right?
Hmm.
So
Because it's old leaves, so it will fall.
old leaves. So all those energy is being transferred to the main branch. Now it's time to die for the leaf. Okay, so such leaf can be get detached by the even the air blows. The same thing, air blow
Ye-
or shaking the branch is the same, right?
Yeah,
Air blow is the natural shaking, and if we do, then is the mechanical. What can we say? Human efforts. Clear? The simple
yeah,
question.
yeah.
Why do you fall in forward direction when a moving bus brakes to a stop and fall backward when you accelerate from the rest? I think we discuss all these now.
Yeah, we discussed this question more than 3 times at least.
So leave it. No point to discuss.
Yeah.
This was my first class to give you some ideas how to write the question, how
Hmm.
to attempt the question. What about the numericals question? How do you attempt the numericals? Do you
Yeah,
have
that
any
no,
do you
that's
have
very
it?
easy.
That's very easy.
Yeah, no. Yeah.
Mm, it's very easy now after getting classes from me or something else.
No, after getting classes from you, it's very easy now.
Very easy.
Yeah,
Then
because in physics I failed mostly the numericals, that's why.
okay, so it's good to hear from you, right? But for example, this is the question, right?
Yeah.
So I would like to read and make you understand. Okay, either you may read. Okay, you are in the weather. Okay, under the weather. A constant force acts on an object of mass 5 kg, right? So
Hmm.
we just as we read the question, we got one, two key points that a constant force act on it. Okay, what the constant force we all know?
Yeah.
Mass we know 5 kg for a duration of 2 seconds. It increases the object's velocity from 3 meter to 7 meter per second. These were the information, right?
Yeah.
So first of all, write the solution, okay, and write those given information. For example, uh, initial velocity, here it is written 3 meter per second, final velocity 7 meter per second, mass 5 kg, and time 2
2
seconds.
seconds.
So first step should be this. Never skip
Yeah.
this. Okay. Never skip. Okay.
Okay.
After writing all these information, if you know there is 4 formulas to solve this question. If you are aware, there are 4 formulas to solve this question. And we are not aware which will suit the best, right? So what you do,
Yeah.
go into the rough page and write all those formulas first. Clear?
Okay.
Now check all, for example, there are the parameters. Find the magnitude of applied force. This is the question, right? So we see
Hmm.
that this is F and mass is given over here. The change in velocity is also given over here and time
And
is also given over here. So we got the idea that all the parameters which are provided is
hmm.
being required in this equation. So we will be happy, okay, this equation will work. There may be some 1, 2 more equations. F is equal to dp over dt, F is equal to a, m into a. We all know all these equations now. F is equal to ma is also
Yeah.
one of the uh, equation for the to calculate the force. So we written all those 3, 4, 5. Okay. If we are lucky that first will fit into the our problem. So once you are confident that okay, this formula is going to work, then do the all the calculation in rough only. right?
Okay. Hmm.
Now, translate those information in your main exercise book. That will be neat and
What?
clean.
I didn't understand what's up.
Whatever you have done in the rough, okay, and you are confident that
Yeah.
this solution is okay. Now the time to translate or bring those solution in the fair place,
Okay.
right? So the
Okay.
solution will be neat and clean.
Hmm.
That's you will be impressing your teacher. See, it's very clean, and he or she will be pleased.
Yeah. Okay.
So, so merely writing all those information what is given to you will take you to the 50%.
Hmm.
The next thing is just to find the appropriate formulas, right? That's it.
Okay.
This concept is again being given by or put forward by a famous Nobel laureate. What I took the name, that was Feynman. So people were making fun of him. See, he's the Nobel laureate and he is saying how to solve the problems. But you can't deny solving problems is first step toward the learning.
Yeah.
Clear? So now you write the answer, but never forget to give the appropriate dimensions.
Yeah.
Force has dimension of newtons. So it may be the
Hmm.
kilogram meter per second square, kilogram meter per second square, kilogram meter 1 second from here and 1 second from here. So it is kilogram meter per second square. If you will write all the dimensions together, mass, kilogram for mass, velocity for meter per second, and time for the second, you will get kilogram meter per second square. Now it's
Okay.
time to translate that kilogram meter per second square to the Newton, right?
Hmm. Hmm.
If you will
Yeah.
leave it kilogram meter per second square, maybe there is no harm. That's true. But if you will say, though, see, this is equal to Newton, then
Hmm.
it will make more impact, right?
Yeah.
Clear?
Yes, sir.
So the final, you can't skip the dimension or unit of the thing. If this is
Yeah.
problem, physics, in mathematics, you will never find the dimensionality. If you are doing area chapter based on the area or length, there only you will find the length or meter square or area square. There people
Yeah.
only write in appropriate unit. But in physics, there's nothing without unit, right?
Yeah.
So every time keep in mind to write the
Unit.
dimensionality or unit at the end. Clear?
Yes, sir.
That's one of the information I given to you. I think. What else? Do you have any doubt?
No.
So I think you will be solving the questions what is given by your teacher. And
Ye-
if you have any doubts, you may ask.
Okay.
Clear? So
Yes, sir.
is today's class was useful or not?
It was useful, sir.
Of course, there is not all the day mathematics. There may be something different.
Yeah.
Okay, so what about this example 8 point? This one of the what can I say? Sweetest
Hmm.
thing in physics is that graphs,
Graphs. Yeah.
reading graph and answering the questions. So in graph, whenever we see the graph, a picture of the quantities comes to our mind, right? So after
Hmm.
processing those information, we see that the x-axis is velocity, sorry, y-axis is velocity and x-axis is time. So this is
Okay.
velocity time graph.
Yeah.
And whenever you see the velocity time graph, as I told that area under velocity time graph gives what? Remember?
Loss of time. velocity on the time graph gives
I,
the
I, I repeated this, I think, couple of times. So
couple.
this is the area and this is the
Yeah, the
triangle,
area
right?
of the triangle.
This is the triangle. So if you will try to find the area of the triangle, if you will see the notes now, I think you will find, or let me show you where is this notes. And where this was, I hardly remember where it was.
Mm.
Velocity time graph, right? It is over here, velocity time graph. Did we solve it for you? Did I solve it for you?
Which
Yeah,
one?
we did. This equation of motions.
Yeah,
So we derived some relation from s is equal to ut plus half of it square, like that.
yeah,
So area under velocity time graph gives equation of motion. This we derive for you as well, right?
yeah. This in
Hmm. So velocity time graph, area under velocity time graph gives displacement. Remember?
yeah, yeah.
Yeah.
Velocity on the time graph gives
Dis-
displacement.
And so one thing they might be asking, the velocity time graph, itna straight along given in this. So what is the question? How much force, how much force does the table exert
Is
to bring it rest? So how we calculate the force?
M into A
So how you will find the A?
by V minus U by T.
V minus U by T. So what is V for the given question?
uh, U is 20 and V is 10.
Okay, then. And time is? What is time?
10. No, so is V is 0
V is 0. Finally, it's touching
and
this
10
X. And time is 10 seconds. Right.
seconds. Yeah.
So using this formula, we will find the force.
Hmm. Yeah.
Okay. So this, I think the way we studied this chapter, you will be able to do the problems as well, right?
Yeah.
So now we are not giving you the assignments, okay? We'll only give you the assignments at the end of the chapter, right? So now you
Yeah.
try to, you do one thing, you stick with your class teacher, whatever she is teaching you, is she or he?
Yeah. Okay.
Okay. So do those problems, the additional exercises as well. Okay. We will be doing our revision over here. Okay. If you feel some concept you have to discuss, okay, you may discuss with me, no problem.
Okay.
Okay. So it's done for today's class. Maybe the next revision class will be in the different fashion.
Okay.
Okay. So get well soon.